All right, guys, let's start off here on number one. So for this one, they tell me that the C down here is 28.7, and so they asked me to find side X. So I need a complete fraction here, so I'm going to need to find angle C, and so anytime I have two angles, I can always subtract them from 180 to find the third angle. So I will go ahead and do that. So 180 minus 70 minus 52 is going to give me 58 degrees up here. And then I'm going to complete my one fraction for law of sines. So sine of 58 over 28.7 equals sine of 52 over x. So we'll go ahead and cross multiply here and divide by, or that'll be 28.7 times sine of 52 equals x times sine of 58. So I'll just divide both sides by sine of 58. And then there we go. And the rest of it's just calculator work here. And so you got to make sure you're in degree mode. And for me, it comes out to 26.668. However, it says round to one decimal place, so I have to write that as 26.7 is my final answer. All right, next up here, we're trying to find the missing angle theta. So for this one, they give me C here is 39. So I know I have sine of 120 over 45. And is this the opposite? It is. That is the opposite side, so I can put this equal to sine of theta over 39. So now I'm going to cross multiply again here. So we got 39 times sine of 120 equals 45 times sine of theta. And so we'll divide that by 45. And then we have to get rid of the sine, so we're going to do a sine inverse of all of that, and that'll tell us what theta is. So I'm going to do sine inverse of 39 sine 120 divided by 45, and that'll give me 48.639. And it says go to the nearest degree, so for me that's going to be 49 degrees. All right, next up here, so they give us, what do they give us? Angle A is 53. And then angle B is 15, and then side C is 75. So anytime I have two angles, I would always find the last angle first by subtracting the other two from 180. And so that's going to give me a 112 here. Okay, and so now I can set this up as sine of 112 over 75. And then I can find whichever side I want first, so I'll do sine of 15 over little b. And then we'll cross multiply there, so these two are going to be multiplying, and then it's going to divide the other one, so 75 times sine of 15 divided by sine of 112 is going to give you b. So I'll go ahead and do that. And I get, let's see, it says two decimal places here, so I'm going to call that 20.94. And so that goes here. And then next up, we'll find side A. So same idea there. We're just going to go sine of 112 over 75 equals sine of 53 over little a. Remember, we cannot use Pythagorean theorem here because it's not a right triangle, so these two will be multiplying 75 sine of 53. The other one will be dividing sine of 112. That's going to equal a little a. So I give us 64.60. All right, next up here, it says use the law of sine to solve for all possible triangles. So I'll go ahead and build my triangle here. So we have 35 here, and then the opposite is 32. That'll be A. And then B, I don't know anything about, but for C, I know that this is 44. So this is angle side side. I'm finding an angle first, and very often this will be the ambiguous case. Let's just check out what happens here. So I'm going to start off with sine of big A. Oh, actually, I know what A is. It's 35 over 32 equals sine of big C over 44. We will go ahead and cross multiply these two known ones together, and then we're going to divide by the bottom there equals sine C. So now I'm going to do the inverse sign on both sides to figure out what C equals. So we're going to do sine inverse of 44 sine 35 divided by 32. And this is going to give me 52.06. It says to round it to 1 decimal place, so I'm going to call that 52.1 for my angle C. However, this is actually just C1. And since that's the first angle I found, I now need to kind of make another triangle over here with C sub 2 as 180 minus that first angle that I found. So it's always you do this to the first, if you find an angle first, you do this to the first angle you find. And so C2 is going to be 127.9. So now I need to build a second triangle over here. So we know then it's actually going to match up with the given information on our first triangle. And then this one's going to be C2 is 127.9, whereas C1 is going to be 52.1. All right, so now we're going to do we're going to subtract 180 from those two angles to find our B sub 2 and our B sub 1 actually. So B sub 1 will be 180 minus 57.1 minus 35. Oh no, that's 52.1 minus 35, okay. So that's going to be 92.9. All right, and then I can find little b by doing sine of 35 over 32 equals sine of 92.9 divided by little b, and then you'll go ahead and cross multiply that like usual, and that'll give you your b sub 1. We already know this one is 92.9. So I'll let you guys do that b sub 1. So then b sub 2, we would do 180 minus 35 minus 127.9. And that'll be 17.1. And then you kind of do that same process to find little b sub 2. You would do sine of 35 over 32 equals sine of 17.1, which is b sub 2 over little b. All right, next up here, kind of same idea. So we got a triangle. We know angle A is 123, and then little a is 21. We don't know angle C, but we know this is 46, and we don't know angle B. So then we will say sine of 123 over 21 equals sine of big C over 46. I am going to have to think about the second triangle in this case once I find angle C. But I'll just set it up here. So 46 sine of 123, and we'll divide the other number, which is 21, equals sine of big C. And now I'm going to type that in my calculator inside of a sine inverse. And as I do that, it says domain error, and so this one actually does not exist. And so you're going to want to write the D, N, E in all of them, okay? The reason why this one doesn't exist, it actually makes sense here, because this angle is 123, which on a triangle would obviously be the biggest angle, but it is not opposite the biggest side, so that's why that one's not possible. All right, next up here, what do they tell me? U equals V equals 24. Okay, so this is 24, and that's 24. And what that also tells me is that these angles right here are the same, because that's an isosceles triangle. And it also tells me then that W is 36. And so let's see, they want angle BCD, and so I'll label this one, let's label this one in yellow. So BCD is right here, that's what they want. That's not the same as my red ones there. I'll do it with 2 lines there. And then they also want DCA, so they want this one up here. Okay, I'll label that one in blue. So they do want this one as well. Okay, cool. So what am I going to do here? Well, it looks like I can start off with a law of sines here. Sine of 30 over 24 equals sine of ADC over 36. And so ADC, Need another color here. I'll do that in this pink here. That is right here. And so I'm going to say 36 times sine of 30. We'll multiply those two together and then divide that by 24 equals sine of ADC. And if I do the sine inverse on this, so sine inverse of 36 sine of 30 divided by 24, that says it is, let's see, round to one decimal place means ADC equals 48.6. However, as you can kind of see here, it looks like the pink angle back here at angle ADC is an obtuse angle. And so for that reason, I'm actually going to call this ADC sub 2. So I'm going to kind of check out the ambiguous case here by subtracting this from 180. And getting that angle. 180 minus 48.6. And that gives me 131.4, which looks like it does fit with this obtuse angle here at 131.4. So with that, I can now find my blue angle up here. It's going to be 180 minus 131.4 minus 30. And that'll give me 18.6 right there. And I can also find the red angle, or the red angles from that 131.4, because I can do just 180 minus 131.4 will give me 48.6. So that's going to go here. And that'll be matching over here, because I said they were it was an isosceles triangle. And so I can do 180 minus I'll do 2 times 48.6, since both of those angles are 48.6, and that's going to give me my yellow angle up top, which will be my final answer to this question. 180 minus 2 times 48.6, and that'll be 82.8. All right, next up here, we got, for me, it's going to be U is 19. And then V is also 19. And then angle X is 40. Angle Y is also 40. And they want us to find the length of AD. So a couple things I notice here. First of all, I see that since both of those sides are 19, I know that this angle must also be 40, just because this is an isosceles triangle here on the left. And so that also allows me to subtract both of those to 180 to figure out that this is 100. And since that's on a straight line with this other angle, I know that one is 80. All right, so that's some good information there. And so now I can get this angle as well. Since I know the other two angles in that small triangle add up to 120, that leaves 60 degrees left for that angle right there. So I think I can already start here with just one law of sines, should do it here. So I have sine on this small triangle here. I'll redraw it. So I have this one as 19, and I have this one as 60, and I have this one as 40, and this is what I'm looking for. So I'm just going to say sine of 60 over 19 equals sine of 40 over x. All right, so we'll go ahead and cross multiply there. So x equals 19 times sine of 40 over sine of 60. And you can just type that in the calculator and see what you get. Just make sure you do 2 decimal places on this one when you get that answer. All right, next up here, it says that these satellites are 40 miles apart. So this will be 40. And so they want to know the distance from the satellite to station A. So I'm going to go ahead and redraw this triangle over here. And I'm actually going to call this one 93 since it shares the straight line with 87 here. I know this one's 84.2. And I know that this down here is 40. And so I'm first looking for this one right here, which I will call x. So I'm going to set up here. We'll have oh, actually I need this last angle. So I'm going to do 180 minus the other two angles. So 180 minus 93 minus 84.2, and that's going to be 2.8 degrees. So I'll do sine of 2.8 over 40 is going to equal sine of 84.2 over x. And so I need x equals 40 times sine of 84.2 over sine of 2.8. All right, so 40 sine 84.2 by sine of 2.8. So that is 814.645, I'll put it. So for this one, I'm going to round that up to 815 because it does say round it off to the nearest mile. And so then for the next part is, excuse me, what's the vertical height of the satellite? So for that one, I'm actually going to drop down a kind of vertical line right here, as you can see. And so if I redraw that triangle now with this side, it is a right triangle. I kind of extended it a little bit there, but I know that this is a right angle now. The hypotenuse, which I just found, is that last answer I just did. And then I know that this angle is 87, and now I want to find what I'll call y, or actually I want to call it height, since it's kind of the altitude here. So now I can just switch to a regular SOHCAHTOA. So I'm just going to say sine of 87 equals h over, and I'm just going to use my previous answer for this. And so I'm just going to multiply my previous answer, since it's already saved in my calculator, over to the other side. And so we'll multiply that by sine of 87. So for me, that comes out to 813. Actually, we're going to round it up to 814 since it's 813.5. And next up here, we got this airplane. Let's see, these miles markers are 7 miles apart. And then we know that this one is 26, and then this one is 54, which actually also means that this one is 26 and that one is 54 because of the alternate interior angles. And so I first want to find kind of this last angle up here, which will be 180 minus 26 minus 54. And so that'll be 100 degrees for me. And so now I'll set this up as sine of 100 over 7 equals, and it does want me to find the distance from the plane to point A, so I'll go ahead and label this x right here. And so then I'll be sine of 54 over x. So now I'll cross multiply here, so I get 7 sine of 54 divided by sine of 100 equals x. So we'll type that all in. And that gives me, let's see, 2 decimal places here, so I'm going to go 5.75. And so now I have that, and so now I actually need to find the elevation of the plane. So that, once again, that's a kind of vertical distance, just like we saw in the previous question. And so it actually builds a right triangle here with this 26 here. This is kind of our previous answer here, that 5.75. And so I would use what? Well, I'm going to use a sine here. So sine of 26 equals h over 5.75. So now I'll just multiply that 5.75 over. I'm actually just going to do my last answer times sine of 26. So that'll give me a 2.52. All right, next up here, let's see, these are 300 feet apart according to my question here. So then I do want to find angle C, which will be 180 minus the other two angles here. All right. So this one's going to be 46, and so it wants the distance from A to C. Actually, I won't label that X since we're already using X, so I'll just call this Y. And so I'll say sine of 46 over 300 equals sine of 52 over Y. And so just do a little cross multiply there. 300 times sine of 52 over sine of 46. So you can type that in the calculator. Obviously, you'll know your numbers will be different. All right, next up here we got talking about the Leaning Tower of Pisa. So that's interesting here. And they says it leans 5.6 degrees from the vertical. And so what that means is, let's see, it's just a little bit of a lean here. So this is actually, if they say from the vertical, it means that right there is a 5.6. And okay, so that's good. So the torus is 106 meters from the base, and the angle of elevation is going to be 28.9. And so remember, the angle of elevation here is always from the horizontal up, so that's why I put that one there. This 5.6 degrees is not an angle of elevation. It says from the vertical, so that's why I am using a vertical line there. However, I'm going to subtract that from 90 to get this one, which would be 84.4, because if it was standing straight up, it would be a 90-degree angle, but this one's just leaning a little bit. So that's that, and then they want the height of the tower x, and so I'm just going to find this last angle by doing 180 minus the two angles I have. And so that comes out to 66.7. And so I can now set up sine of 66.7 over 106 equals sine of 28.9 over x, and then do your cross multiplying there. All right, next up here we got this diagram with the tree. The tree is vertical, and so you got a bunch of dimensions here, and so I'm actually going to draw two triangles here that kind of represent this. So the first one I'll kind of outline right here with my green, and then I'll redraw it over here. So what we know on this one is that this distance right here is our 225. You can see it's kind of at a slant there. And then let's see, this whole angle A is 53, but the little angle B is 23. So I'm actually going to say that this is 30 degrees because I got that from subtracting, because this is actually A minus B right here, because you can see angle A is kind of the whole angle, and I'm just doing like a piece of that. So that's all I know on that one so far. And so now I'm going to draw one more triangle here. So I'll do this one. Let's see, I'll use pink here. So that's going to be this triangle. Now that's actually going to be a right triangle, because we're saying that the tree is kind of growing vertically here, and we know that this angle A, this is our full angle A now, which is 53 degrees, and really the only thing I need this triangle for is to figure out this other angle. So I'm going to do 180 minus 90 minus 53. And so this other angle is 37. You can actually see that that matches up over here on this one as 37. So we want to know the height of the tree right here. And so I can already use a law of sine. So I'm going to say sine of 37 over 225 equals sine of 30 over x. And if I just solve that, that'll tell me the height of the tree. All right, next one here is asking us to express the length x in terms of the trigonometric ratio of theta. And so what I would say here is I'm actually going to find, I can't go straight from theta to x right away, so I'm going to kind of find this thing I'm going to call y right here. And so from theta, I would say that we have that. And so now I can set up actually a tangent of theta as y over 25, which means that y equals 25 times tangent of theta. So that's nice right there. And so I'm going to kind of keep going here, and I kind of also realize here that this other angle here must be 90 minus theta. And since it's always kind of the other angle on a right triangle is 90 minus the other angle. But I also notice here that they said that this is a right angle, which means that this little angle in here, or it's not that little, but is 90 minus the pink 90 minus theta that I drew right above it, since it's sharing the 90-degree angle. Well, if we kind of simplify that, the 90 minus 90 plus theta, if you distribute the negative, means that this is actually just theta. So I can build another trig ratio here for theta. I can say now on my yellow triangle, my yellow theta, I can say that sine of theta equals x over y, which means that x equals y times the sine of theta. And so now what I can do is just substitute in this right here, since when it says in terms of theta, that means that should be my only variable, and y was kind of a made-up variable anyway. So I'm going to say 25 tan theta times the sine theta is equal to x. All right, next up here, they want, so this is a right triangle, so they want the measurement of the non-given angle. And so I'm just going to subtract that from 90, so it's going to be 38. And then the length, oh wait, no, that's the other acute angle, that is down here. All right, and so then they want the length, the side opposite here. So for this one, I would use a tangent. It is a right triangle, so we can use SOHCAHTOA, and that'll be x over 35, and then so you would just multiply that over. So it would be 35 times tangent of 52. So whatever that is, I would put it right there. And the length of the hypotenuse, I would say that that is, call that y. Sine of, actually I'd have to use sine of 38 here, or you could use cosine of 52. It'll give you the same thing. So I'll just go use cosine of 52 equals 35 over y. Now on this one, because the variable is on bottom, it's going to be 35 over cosine of 52. All right, next up here, it's asking me about a bunch of trig ratios, and I only have two sides, so I would always find the third side first using Pythagorean. So I'll do 12 squared plus 21, oh no, it's not, plus, we'll call it b squared equals 21 squared. So that's 144 plus b squared equals, let's see, 21 squared is 441. And b squared is 297, and we'll square root that. Now I do always want to break down the radical here. So does 297 break down? Yes, it looks like it's going to divide by 9, since the digits add up to a divisible by 9 number. So it'll be that, 3 and 11, and then 3 and 3. So we do have twin 3's here, so they will go outside and as 1. And then the loners will go back in the house and multiply. So this has got to be 3 rad 33. So from there, sine of alpha would be 12 over 21. And they said and cosine of beta, and you can see that that actually is the same. And this is kind of like what we're talking about here with the, this one is really 90 minus alpha. And we know that sine of one angle is always the same as cosine of the other angle. And so that's what we're really exploring right there. And so tangent of alpha would be 12 over 3 rad 33. I might reduce that to 4 over rad 33. We can reduce kind of outside the radical with outside the radical. And then lastly we have, oh, and once again that's the same as cotangent of b, because we're moving to the other angle then. And then lastly, secant of alpha. So secant of alpha is the reciprocal of cosine. So I haven't done cosine of alpha yet. So cosine of alpha would be 3 rad 33 over 21. And so this is going to be the reciprocal of that. So 21 over 3 rad 33. Which I would reduce to 7 over radical 33. All right, next up here, they say that this is an arithmetic sequence, so there should be some consistent adding or subtracting here. And I can see it looks like they're adding s every time. Looks like the 4 is not changing, but they're just adding s. So I'd say the common difference is s. A sub 5 then would be actually the next term here. So if we just track this pattern, it would be 4 plus 4s. And then a sub n, for this one, I would say a sub n equals, I always say it's like mx plus b. So I just kind of translate that to dn plus a sub 0. And so d we already know is s. And n we leave as a variable. Now a sub 0 would be kind of the hypothetical term in front of the first term. So that'd actually be 4 minus s if we kind of take this pattern backwards. So I'm going to say plus 4 minus s. So I'll say Sn plus 4 minus S. And then this allows me to find A sub 100, because I can just plug in 100 for S. So that would be 100 for N. So it would be 100S plus 4 minus S, which would reduce to 99S plus 4. All right, next up here, this is it's another arithmetic sequence, and it's giving me two random terms here. It's saying A sub 14 is 2 over 3, and it's saying A sub 9 is 1 over 4. And so I always think of this as like linear, so the common difference is really the slope. And so the slope will be y2 minus y1 over x2 minus x1. The x's are always a subscript here. I could have done this in the other order as long as I kind of switched both of these. And so let's see. I know the bottom is 5 here, but I'm going to need a common denominator up top, so I'm going to change those into 12. So this will be 8 over 12 minus 3 over 12. And so that's going to be 5 over 12. And when I multiply by the reciprocal here, 1 over 5, you can see that these cancel, and we get our common difference at 1 over 12. All right, so then next up, I need to kind of I'm actually going to write a formula for this first. And so I'm going to say A sub n equals, and it's usually dn, so I'm going to say 1 over 12 n plus whatever A sub 0 is. And to find A sub 0, I'm going to plug in one of these points. I'll go ahead and use this one, so I'll say 1 over 4, I'll plug in right there, and I have to plug in a 9 for n, not a 12. 1 over 12 times, I'll plug in 9 for n, I'll call it 9 over 1, plus A sub 0. And then, so I'll go ahead and multiply these, so let's cross cancel to 3 over 4, which is actually nice here because this will turn into 1 over 4 equals 3 over 4 plus A sub 0. So subtract the 3 over 4 over, and we know A sub 0 is negative 1/2, or negative 4, or negative 2 over 4. So now I can say that my A sub n equals 1 over 12 n minus 1/2. And so now I can plug in 1 to get A sub 1 at 1 over 12 minus 1/2, which is 1 over 12 minus 6 over 12, which is negative 5 over 12. All right, next up here, we got the cows, and so they want the average and the median. So for the average, we just add them all up and then divide by the number of numbers. 960, 920, 890, 980, 930, and 900. And so for me, that's going to be a 6450 divided by, how many do we have here? We have 7. And nearest whole number, that's going to be 921. Okay, so then for median, we do have to put them in order here. So I'm going to do the 870, and then 890, and then 900, and then 920, 930, 960, and 980. Okay, so then we count in here. So we go 1, 2, or 1, 1, 2, 2, 3, 3, and then the median right there is at 4 at 920. All right, how many cows are above average? Well, above 921, you can see is 3 of the cows. And then they will purchase a calf that weighs 400 pounds. And so what happens when we put a 400 here? So for my average, I know I can just kind of adjust this by doing plus 400 up here and then divide that by 8. And so I'm going to do 6450 plus 400 and then divide that by 8. So that drops my average down to 856.25. Oh, they say the nearest whole number, so let's do the 856. And then when I'm doing my median here, now I'll count it in green. So I have 1, 1, and then 2, 2, 3, 3. 4, 4, so we have 2 medians here, 900 and 920. So when that happens, we average them out, and so that's going to be 910. So I would say that the median here is a better indicator of the central tendency, and that's because you can see that this one outlier really affected the mean a lot, but didn't really affect the median too much. And that just kind of goes along with what we're going to say here for part D, which is that that outliers affect the mean more than they affect the median.